Going to see how the gates and logics, combination logics, sequential logics are going to implement using the Xilinx, right? So the tool name is ISC Design Suite. So ISC Design Suite 14.6. So just double click the shortcut program and this window will get opened. So you just close everything and here go to file and create a new project, right? So in new project, so in this you have to give the project name, right? So say for example project 2, right? So give the name of the project and you have to choose the location where you are going to store the program, right? So in double click, so you just click the location and select somewhere in the computer, my computer, and select the location D. So in this location I have already created the folders as the IT. So in this location you choose the IT B folder, or else if you are doing individually you have to create the register number by new folder. So click the new folder and click OK, and again ensure that the HDL language is selected in the source type, right? Again next. So here we have to look in the 3 parameters. So in the above level you don't need to depend on the families devices, that is fixed, that's okay. Here ensure that synthesis level is XST, simulator level is ISM, and preferred level language is VHDL. So we are going to do the VHDL program, right? So here in some cases Verilog has been selected. So now we need VHDL. So synthesis level XST, simulator ISM, preferred language VHDL. So ensure these 3 options and then select next and then finish. So now go to project and create a new source. Create a new source. Here we have to select the VHDL model, right? VHDL model, we have to give the file name. So this file name should not be same as the project name which we have given the last time. So file name you can create program 1. Program 1. So next. So once give the program, so a new wizard is getting open. So in this wizard we have to give the port names. So here first we are going to try with the OR gate. OR gate is 2 inputs and one output. So name the ports A, B and C. So A, B is input, C is output. So A in, B in, C is out. So this is the direction we are going to select. So say for example if you are giving for an off adder means A, B, sum and carry. A and B will be the input, sum and carry will be the output. So we are creating the ports and we are giving the name. Then next, then finish. So as R told that 3 types of programming level, behavioral, gate level, structural level. So here the program is created with behavioral level. One entity, common entity, behavior level it has been created. So program window will gets open, right? So what here I have to type the program, rest of the program. So for a simple or experiment, so what we have to type, C is less than or equal to A or B and then colon. So for unblocking statement we have to give this. So once typing the program, then you have to save the save. You have to run. Before running we have to check, as similar to the C program. How you check? Before you run you have to compile the program. So similar to this language, this tool, we have to synthesize the program, right? So in the left side we have synthesis. So double click the synthesize tool, it keeps on synthesizing. So once the system keeps on checking the structure of the entire program, so whether it is okay, double click when we get the green tick, then this is okay, then this is ready to run. So after synthesizing we go to simulation. So just click the simulation and click the program. Click the program behavior 1. So in this program behavior, this program is getting selected and now it is ready for simulate. So once click here, then now click the expand the window, expand the iSim simulator window. This window expand, and now double click the simulate behavior model. Double click the simulate behavior model. The final graph window will get open. The graph window will get open. Now here we have to feed the input values. So what we have designed? A simple OR gate A, B and C. So now we are going to give the inputs for A and B by just click and right click the value, right click the A in this, select the force constant, we have to select the force to value. So by click this, give the input 0, apply and OK. For B, right click, force constant, force value 0, apply and OK. So once give the input with A and B, then we will give the run. So this is the run for time specific period 1 microsecond, then run. So A and B is 0 0, then C is 0. So we have 4 combinations. We know that 0 0 0 1 1 0 1 1. So now A is 0, B is 1. Going to replace with 1. Apply and click. Then once we run, then this will get changed. 0 and 1. C is 1. And now
1 0.
Force constant. The value is 1. Apply OK. Here the value is
0.
0. Then if you run, value is 1. So by zooming this graph window, we can visualize the physical output. So the graph will get changed, right? So this is the line for A, this is the line for B, and this is the line for C. So this will have a variations. So in this way we have to simulate all the remaining gates, XOR gates, AND gates, NAND gates, and able to do all the remaining possible combinational and sequential logic, half adder, full adders, right? Yeah, that's it.
Yes.